Okay, so here we go. In problems 49 through 72, function f is one-to-one. So they tell you you're dealing with a one-to-one function. If they have to, they'll restrict the domain. That's where you'll see that x is greater than or equal to 2. That's so the function is one-to-one. That you don't really need to worry about. Find its inverse and check your answer, and then state the range in the domain of the function and its inverse. So if I take a look at the function is x cubed plus 1. That's that S curve moved up 1 unit. So what do I know that the domain of f, what is it? All real numbers, no denominator, no radical, so it's got to be all real numbers. Step 1, replace f of x by y. So y is equal to x cubed plus 1. Step 2, interchange x and y. X is equal to y cubed plus 1. Step 3, solve for y. So I need to get y by itself, so x minus 1 equals y cubed. Who do I assume is going to be his inverse? What's it going to involve? Cube root, because what is the inverse of x cubed? Cube root. So it's going to be cube root, so take the cube root of both sides, and since it is a cube root, I don't need the plus or minus. Y cubed. So that y equals the cubed root of x minus 1. Now that happens to be what f inverse of x equals. It is the cubed root of x minus 1. And so what is the domain of f inverse? All real numbers. So we got the domains taken care of. By the way, if you know the domain of the function, you know the domain of the inverse, you know the ranges. And we'll talk about that when we get down to the bottom of the page. Now verify. I only pick one. I'm going to go ahead and just do f of f inverse. So verify f of f inverse of x. I need to have it equal x. That says I've got the right guy. So that means in the function f, which is x cubed plus 1, I have x cubed plus 1. Wherever I have an x, I'm going to put the inverse function. So the inverse function is the cube root of x minus 1 cubed. And if I cube the cube root of x minus 1, what do I get? X minus 1 plus 1, that equals x, and it verifies. So I have found the inverse. Now it says down at the bottom, what's the domain of f? Well, we found the domain of f is all real numbers. And we found, and this should be inverse, the domain of f inverse is also all real numbers. Now here's the thing. What do I know? I know that in this case, I'm going to draw 2 pictures, and sometimes this is really helpful. This thing goes from the domain to the range. So this takes all real numbers to whatever is there. And at the moment, I don't know what's there. And the inverse takes whatever is there back to here. And what do we know the domain of the inverse is? So that says, what's the range of the function? Well, if this is the range of the function is all real numbers. And the range of the inverse is over here. It's all real numbers. Now, let's use a different example so we get a better feel for it. And this is just going to be kind of a nebulous example. So that if I know this is the domain and I know that this is the range, and say the domain here is x greater than or equal to 2, and for the inverse, the domain is x can't be 1. Now that's weird. But it doesn't matter, because the function f takes all x's that are greater than or equal to 2 to this guy. So when I look at the domain of the function is x greater than or equal to 2. What's the range of the function? Not x is not equal to 1, because ranges are not x's but y's. Now the inverse comes back this way. So the domain of f inverse would be what? Now I'm starting here, and I'm completely ignoring it. So this is my home. So what's his domain? Yeah, x can't be 1. And what's the range of the inverse? And now I'm over here. But it's no longer x's to the inverse. The x's are become what? Y's.
So up at the top, the domain of the function x is greater than or equal to 2, right? Not 0.
Oh, 2, yeah.
Okay, that's fine.
Thank you.
Confused.
Yeah, thank you. Because you flipped x's and y's.